So this project delivers a transit demonstrator fuel cell electric vehicle.
This is a 12-month project as part of the Advanced Route to Market competition.
The APC ARMD funding enabled the project to go ahead with reduced risk and reduced cost to both companies.
The two main aims of this project are, number one, to convert a battery electric vehicle, specifically the Ford Transit, into a working fuel cell demonstrator, and number two, produce a digital toolset to simulate fuel cells in vehicle application.
So AVL and Ford have a very long and extensive working relationship within the UK, and we've covered a multitude of different areas, so working with Ford on calibration projects, controls projects, both simulation projects and design and component engineering projects as well. Our transportation sector, and hence our propulsion systems, significantly contribute to the amount of CO2 that's emitted each year globally. So it's really important that any technology choice we have has at the very heart of it the ability to reduce our CO2 footprint and becomes part of the solution to reduce our CO2 levels being emitted.
So the energy demands of light commercial vehicle customers varies hugely depending on the usage of that customer and the payload they're carrying. Currently today that's not really an issue because they can quickly and easily refill at any petrol or diesel filling station. Hydrogen and hydrogen fuel cells offers us a potential zero CO2 alternative to battery electric vehicles, but with the quick, convenient filling experience of a diesel or petrol vehicle.
It's afforded us the opportunity to really consolidate our fuel cell system capability within the UK, and that's across the board. So that's everything ranging from component and system design and specification for both the stack, the balance of plant and the hydrogen storage systems, to developing the control systems for both the stack and also the high pressure hydrogen storage systems as well. It's allowed us to develop a tool set and a simulation platform whereby we can simulate the fuel cell stack within its system, but also within a vehicle environment as well.
When we look at fuel cells, the big advantage that we have is that we're storing the hydrogen on board the vehicle. This gives us a very fast refuel time, so typically about 5 minutes, very similar to today's vehicles. When I talk about 5 minutes, it sounds like a long time. But when you think about how you fill up with a typical petrol or diesel vehicle today, actually it's not much more. So it really will have the advantages of today's systems with the convenience of today's filling stations. So one of the things that's often brought up for fuel cell vehicles is the availability of hydrogen. Today, that is a problem here in the UK, and that's one of the major perceptions that we see. But when we start to look at the need for climate change and what is happening on a global basis, we're seeing a lot of governments pushing for hydrogen. So in terms of hydrogen safety on the vehicle, we are putting lots and lots of safety systems around in order to detect any potential leakage, and the vehicle will shut down, making the vehicle completely safe to operate. So I personally believe that hydrogen is one of the major fuels of the future.
AVL has over 18 years experience in fuel cell system development. We have more than 250 engineers working globally on fuel cell projects, and we have 3 fuel cell technical centres worldwide. Within our vehicle centre, we've also increased our capability to not only build fuel cell stack system assemblies, but also to integrate those into fully functioning vehicles and commission those vehicles ready for use on the track. The knowledge and consolidation of our expertise on this fuel cell R&D project has allowed us now to support both global AVL fuel cell projects, but it also allows us now to support and lead fuel cell projects from the UK to support our UK market and our UK customers.
The highlight of the project for me really has been working with lots of people in this project. Although we've been not working physically together, a lot of the work has been done remotely. I couldn't have seen it being done in any other way if we didn't have all the support and a great team working together.